Devin is attending a local festival downtown. He plans to park his car in a parking garage that operates from 7 a.m. to 10 p.m. and it charges $5 for the first hour and $2 for each additional hour of parking. Create a linear graph that represents this relationship and what is an appropriate domain and range for the given situation. Alright, so this is a linear relationship because we start off at 5, that's our y-intercept, and then we charge an extra $2 for each additional hour, and that's our slope. And the key here is each. So this is a simple y equals mx plus b formula. Here's y is equal to our slope. So that's $2 per hour plus the $5 that we initially invested. What is the appropriate domain and range? So we're going to need to know how much money he ends up spending in total and how many hours he's in there for. So we have to figure out how many hours he's in there for. So it operates from 7 a.m. to 10 p.m. That's when he plans on parking. So this is 7 a.m. to 10 p.m. There's 12 whole hours in there to get to p.m. and then another 3. So this is 15 hours. Is in there for 15 hours. Okay. And I can start with my domain now. So he's in there from 0 to 15. How can I write this as a domain with inequality format? Well, I can do 0 less than or equal to x less than or equal to 15. Okay, you always want your lowest number on the left-hand side and the highest number on the right. And now we're just going to put this down below, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 intervals. So we're going to do intervals of, we're going to do 2, because that'll fit. So 2, 4, 6, 8, 10, 12, 14, 16. Okay. And now let's figure out how much money he ends up spending. So he starts off at $5, and then after 15 hours, okay, he spends $35, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 intervals. I think we can get away with doing interval of 4. So interval every 4. So $4, 8, 12, 16, 20, 24, 28, 32, 36. Okay. So he started off at $5, and we use y to represent our y-axis, and he went all the way up to 35. Okay, now we can graph him. So we start off at 0. Here's 0, and he paid $5. It's right above the 4. And then after 15 hours, so that's between the 14 and the 16, he spent 35. So that's going to be right here. It's going to go ahead and draw a line now. And so now we can see our domain is from 0 to 15, and our range is from 5 to 35. One thing to look out for is sometimes they don't use x for domain; they would use time. This would be this might be one of those cases because this is the amount of time that went by. All right, let's look at our next problem. Suppose you fill your truck's tank with fuel and begin driving down the highway for a road trip. Assume that as you drive, the number of minutes since you filled the tank and the number of gallons remaining in the tank are related to a linear function. All right, so they're helping us out. They're telling us it's a line. After 40 minutes, you have 28.4 gallons left. An hour after filling up, you have 26.25. Graph the relationship and how many hours until you run out of fuel. All right, so first thing, let's find the slope. From 40 to an hour, that's a change of 20. And from 28.4, we decreased to 26.25. So let's calculate that on our calculator. If we have 28 or 26.25 gallons in our tank, and we did have 28.4. We subtract the 28.4. And we've lost 2.15 gallons in 20 minutes. Okay, let's divide this by 20 to see how much gallons of gas we're using per minute. And that is a slope is negative 0.1075. All right. So what do we do now? Okay, so we got the slope. Let's create ourselves a linear function with this information, and then we're going to try to figure out, we want to know how many hours till we run out of gas. So we're going to find out the starting point, because we got to graph it, and then the x-intercept. So I'm going to take my slope, I'm going to plug it into our transformation formula. So this is negative 0.1075. And I'm going to pick 40 and 28.4. So after 40 minutes, that's x minus 40. After 40 minutes went by, we're now at 28.4 gallons of gas. Okay. So this says I'm losing negative 0.1075 gallons per minute. 40 minutes went by, and I have 28.4 gallons of gas. So we're going to distribute this negative 0.1075. And I know this is a tiny number, but we're going to multiply that into negative 40. And that's 4.3. So we've used 4.3 gallons of gas. And if we add that to the 28.4 that we currently have, we know how much we started off with. So we started off with 32.4 gallons of gas. All right, so let's try to fit all this in. I'm not exactly sure when I'm going to run out of gas or how many hours or minutes that went by, but I know that I'm going to have 32.7 gallons of gas to start off with. All right, so I need to do maybe intervals of 4 again. So 4, 8, 12, 16, 20, 24, 28, 32, 36. And I'm going to come up here right around 32. I'm going to put my first point. I know it's getting a little messy, but that's what markers do. Okay. So when do I run out of gas? I run out of gas when my y value is 0. So let's make that 0. When y is 0, that means it's going to hit this line right here. 0 is equal to negative 0.1075x plus 32.7. I'm going to solve for x now. So I got to move the 32.7 onto the other side. And then I need to divide by this negative 0.175, both of these numbers. Okay, so I already have 32.7 in my calculator. I'm just going to turn them negative, and I'm going to divide by 0.1075 negative. And that's how many minutes that went by. All right, so 304 minutes. It's going to be kind of hard to put on here. Let's do intervals of like 30, 60, 90, 120, 150. No, 30 is not going to work. Let's do intervals of 40. 40 should work. So 40, 80, 120, 160, 200, 240, 280, 320. All right, still kind of hard to see, but now we can kind of graph it. So we go from here and down here between 280 and 320. And it says how many hours will it take for you to run out of fuel? So this is minutes, but we need to divide it by 60 because we're talking about hours. And that's a little over 5 hours. We're going to round this down about 5 hours.